Hi everyone, this is our seventh lecture in Unit 1 groups. In this lecture, we are going to discuss about cosets and its problems. So let us have the definition of cosets now. So let H be a subgroup of the main group G. Let us consider one arbitrary element from G. Then the set AH is equal to A star H such that H belongs to the subgroup H is called the left coset of H. Sometimes AH is also written as A star H. Next, the set HA is equal to H star A such that H belongs to the subgroup H. Means we call it this HA is the right coset of H in G. Which means A presenting in the left of H means left coset, right in the H means right coset. Note, if H is finite, H and AH have same elements means we written as order of H is equal to order of AH. Order of H is nothing but number of elements in H. Let us move on to the problems under this category. Find the left coset of the subgroup H. H they are given 0, 3 of the main group Z6 under the addition modulo 6. So H is the subgroup of the main group Z6. Here main group is Z6, right? Now given Z6 containing the elements are 0, 1, 2, 3, 4 and 5 and they are given the subgroup H containing the elements 0, 3. So this H is a subgroup of the main group Z6. The left coset of H we may written as, because here they are given addition modulo, right? So therefore A plus H is equal to A plus 0, A plus 3. Whatever we are doing in the left hand side, we must do in the right side also. Here we must choose this A from Z6. Now in place of A, we are going to replace Z values 0 to 5 one by one. Now we are going to substitute Z values one by one. First I am replacing 0 in place of A. I will get 0, 3. 0, 3 is nothing but H. H is 0, 3. So next I am replacing 1 in place of A. I will get 1 plus H is equal to, so 1, 4. 1, 4. When I am get 1, 4, in H is equal to 0, 3, right? While I am adding 1 with H, I will get 1, 4. So therefore, I may rewrite this 1, 4 as 1 plus H. So next 2. 2 plus H is equal to, I will get the result 2, 5. While I am adding 2 with H, I will get 2, 5. So therefore, I may rewrite this as 2 plus H. Next 3. While I am replacing 3, I will get the elements or 3, 6. So this is nothing but it exceeds 5, right? So it exceeds 5 means we need to replace 0. So therefore 3 comma 6 is, I will get 3 comma 0. So therefore this is nothing but H, right? So therefore 3 plus H gives H. 4 plus H, I will get 4 comma 1. 4 comma 1 means while I am adding 1 with H, I will get 4 comma 1. So therefore this is nothing but 1 plus H. And finally 5. 5 plus H gives the result 5 comma 2. So 5 comma 2 we can rearrange this as 2 comma 5. So when I am adding 2 with H, I will get this 2 comma 5, right? So therefore this gives 2 plus H. Now look at the distinct coset from the above results. So H. So 0 plus H and 3 plus H gives the result H. So therefore you will choose only once H, comma. So next 1 plus H and 4 plus H gives the result 1 plus H. We may take once only. So therefore 1 plus H, comma. 2 plus H and 5 plus H give the same result 2 plus H. So therefore distinct cosets of the given set is h comma 1 plus h comma 2 plus h. These are all the different cosets of the given set. So let us move on to the next problem. Determine all cosets of subgroup h is equal to 1 comma a square of your group main group g is equal to 1 comma a square comma a cube. Look at these two groups. Subgroup mm, must contain the elements in the main group, right? 1 comma a square is in the main group g. So therefore h is a perfect subgroup of g. So we need to find out cosets of the subgroup in the main group G under multiplication, where they are given a power 4 is equal to 1. Whenever you are getting a power 4, we must need to replace 1. Now solution, given G is equal to 1 a square a cube, and they are given the condition a power 4 is equal to 1 is a group multiplication. So and h is equal to 1 comma a square is a subgroup. We shall find all these left cosets of h. So now h is equal to the elements of the main group or 1 a square a cube. We need to find out the left cosets, right? We are going to multiply one by one each main group element with h in the left hand side. So therefore 1 into h gives 1 dot h. Here we are doing multiplication. This small h belongs to the subgroup G. So therefore h 1 dot h, which is equal to h is nothing but uh, the so h belongs to capital H, right? So h is the result. H is nothing but 1 by a 1 comma a square. They are given the subgroup h is 1 comma a square. So therefore the result is 1 comma a square. So which is equal to capital H. So next a h. AH means A dot H. So we are multiplying H with A. So H is nothing but 1 comma A square. So 1 into A, so 1 into A and A into A square. This gives A comma A cube. Next, we want A square. A square into H is equal to right hand side A square dot H. We are taking dot product of A square with this H. H is 1 comma a square. So therefore a square dot 1 comma a square dot a square. This gives a square comma a power 4. They itself given the condition a power 4 is equal to 1. So therefore a square h is equal to a square comma 1. So 1 comma a square is nothing but h, the subgroup. At last a cube into h is equal to a cube dot h. H is 1 comma a square. A cube dot 1 comma a cube dot a square. So therefore a cube comma a power 5. A power 4 is 1. So therefore a power 5 value is 1 dot a. So therefore this answer is a cube comma a. So at last look at the above results. A comma a cube is repeating two times. We want to take only once, and h also we are getting two times. We need to take only once. So there are two left cosets of h in G are 1 comma a square and a comma a cube. The index of h in G is 2. Since G is cyclic and hence abelian, H is a normal subgroup of G. So every left coset is also a right coset. Thank you.